Unit 2, Lesson 12, Proofs about Quadrilaterals. So our learning goal is let's prove theorems about quadrilaterals and their diagonals. So again, diagonals, just for those who just saw that word and were like, wait, what? Diagonals would be like something like that. Okay, something that cuts across diagonally, if you will, in orientation of the given figure. Okay. All right, so first things first, let's look at some definitions. All right, we have the good old-fashioned rectangle here. Right, is a quadrilateral. Again, that's a four-sided gong. Okay, gon, polygon, get it? So four-sided gon with four right angles. So 1, 2, 3, 4. Question: could a rectangle be considered a parallelogram also? All right, think about it. Think about it. All right, so four right angles is the main idea for the rectangle. All right, so 12.1, it's our warm up. Play with parallelograms. Okay, so which statement do you agree with? All rectangles are parallelograms. All parallelograms are rectangles. What do you think? So notice what we have here is the converse, right? So instead of if P then Q, it's if Q then P, right? So which statements do you agree with? A rectangle, all rectangles are parallelograms? Well, all rectangles have to have 90-degree angles, right? Based off the definition from earlier. What about all parallelograms are rectangles? So go ahead and pause this and think about that and which ones do you agree with and not. All right, so hopefully you paused it and gave yourself some time and you realize that the first statement that is definitely true, and the second statement, the converse of it, is false. For example, right, and if you did this with the GeoGebra link earlier, right, you would realize that, okay, this drawing might not be 100% perfect here, but I want to pretend that this side here is parallel to that side there. This side here is parallel to this side here, okay? That's a parallelogram, okay? But these are not right angles, right? So hopefully you realize second one is false, right? You just have to give one example. All right, which figures, if any, are always rectangles? This is number one. Which figures, if any, are always rectangles? Which figures can be dragged to make a rectangle? So what about squares? Is squares technically a rectangle? It's like, what's the definition? A rectangle is a quadrilateral with four right angles. That's interesting. So which figures, if any, are always rectangles? All right, rectangles themselves. Are squares included in that? Right, which figures can be dragged to make a rectangle? Which figures can be dragged to make a rectangle? I'm not sure what they're asking there. What do you guys think? Like maybe changing the angles? Like, I don't know. Maybe a rhombus? What do you guys think? All right, so number two. Again, I want you to pontificate those ones. Which figures, if any, are always parallelograms? Which figures can be dragged to make a parallelogram? So, what about a rhombus? Would a rhombus work? Would a square technically be a parallelogram? Would a rectangle technically be a parallelogram? What do you guys think? Okay. Which figures can be dragged to make a parallelogram? I don't know if that is something to do with the GeoGebra link up here. Okay. We'll see. All right. A rhombus is a quadrilateral with four congruent sides. Okay. So notice how they don't mention anything about the angles. They just mention four congruent sides, like a square, right? like a square. Okay. Now, are all the sides are the opposite sides also going to be parallel to one another? Like, is KN going to be always parallel to LM? What do you think? What do you think? Okay. All right. 12.2 from conjecture to proof. So here are some conjectures. All rectangles are parallelograms. Okay. So I was kind of elaborating that earlier, right? If a parallelogram has at least one right angle, then it's a rectangle. All right. So if you know that it's a parallelogram, but it's got a right angle, guess what? It's going to force all the other angles to basically be 90-degree angles as well. All right. If a quadrilateral has two pairs of opposite sides that are congruent, then it is a parallelogram. All right. So that's this situation. You have something like this. You find out that this side is parallel to that side, and ta-da, it's a parallelogram. All right. That would have helped with the proof last couple lessons ago, right? Because immediately I could have just been like, oh, well, then therefore these two sides have to be parallel, right? So next one, if the diagonals of a quadrilateral both intersect each other or bisect each other, then the quadrilateral is a parallelogram. So basically what we're saying here is this. Here are your diagonals. If they cut each other both in half, this side will be the same as that side. This side will be the same as this side. And as long as they're bisecting each other, guess what? You got a parallelogram. Okay. Let's see. If the diagonals of a quadrilateral both intersect each other or bisect each other, they are perpendicular, then they are then the quadrilateral is a rhombus. So not only do they diagonals have to bisect each other and are perpendicular, then you're a rhombus. Okay. So for example, if I can draw one correctly. Okay, I'm hoping I get the angles here right. It's not completely constructed to perfection here, but get the idea. So here's one diagonal. Here's two diagonals. Again, if we got something like that, all right, they bisect each other and they're perpendicular. Okay, then you are definitely a rhombus. Okay. All right, so pick one conjecture and use technology to convince yourself this is true. So I highly recommend that you use GeoGebra and test those ideas. Okay, like how I just drew right my shapes, but you can totally use GeoGebra to construct your own situations. All right. All right. Second, rewrite the conjecture to identify the given information and the statement to prove. Let's see, rewrite the conjecture to identify the given information. And so from your drawing, basically on GeoGebra, you're going to basically look at whichever conjecture you're focused on. Like all rectangles are parallelograms, right? The given information for that situation is that maybe all four angles are right angles, right? That's information that needs to be given in order to prove that. Okay, so that's what they're talking about with number two. Draw a diagram of the situation, mark the given information, and any information you can figure out for sure. So that again is on GeoGebra when you create your actual image or figure. 4, write a rough draft on how you might prove the conjecture is true. So if this, then that. Okay, definitely use the definitions for that part. Okay, lastly, for definitions, parallelogram. If a parallelogram has at least one right angle, then it is a rectangle. Okay, so if that is given to you and you know that the opposite sides are parallel to each other, it's a rectangle. Okay, and that's always. All right, so in summary, why do we spend so much time learning about triangles are being congruent? Because we can decompose other shapes into triangles. For example, what they're talking about is, notice how they take this quadrilateral down below and then they break it into 4 different triangles. In doing so, you can apply triangle congruency theorems, okay, and then possibly use CPCTC or other means to prove certain angles, certain parts are congruent, um, or are even a certain shape. So let's see. We've learned some more about the quadrilaterals today, right? We talked about a parallelogram is a quadrilateral with both pairs of opposite sides being parallel. We learned about a rectangle, right? 4 right angles. A rhombus, 4 congruent sides. A square is a quadrilateral with 4 angles and 4 congruent sides. So it's basically when a rectangle and a rhombus meet up, right? They pop out a square. Okay. A kite is a quadrilateral that has 2 sides next to each other that are congruent, where the other 2 sides are also congruent. So very much down below, okay, as an example. All right, so in this example they give down below, they say knowing how to decompose quadrilaterals into triangles using their diagonals lets us prove how different quadrilaterals definitions lead to the diagonals having different properties, okay? So notice how they did create some diagonals here. Let me clean this up a bit. Right, they gave us this diagonal here, right? And in this statement, they say one diagonal is perpendicular bisector of the other, and the figure is a kite. Okay. In quadrilateral ABCD, so the image I just highlighted there, the diagonals AC and BD that intersect at point P. All right, so they go ahead and they give us the fact that we got a perpendicular bisector, which means a 90-degree angle, right? And what else do they give us? Segment AP is congruent to PC, so let me mark that. AP is congruent to PC. And what else do they give us? AC is perpendicular to BD, which is the 90-degree angle right there. Prove segment AB is congruent to segment BC. So we're trying to prove that AB is congruent to BC. Now, vertical angles, that's 90 degrees, right? And definition of a line of AC makes that a 90-degree angle, right? Does everybody agree that we have this side here being congruent to itself? So not only do you have 2 sides here, angles here, but also have sides here with the reflexive property. Those 2 triangles are side angle side triangle congruence. Therefore, AB is congruent to BC. So notice how we use diagonals to break down this quadrilateral, right? Which we're trying to prove that AB is congruent to BC because it's a kite, right? So we can still use triangle congruencies to help us prove this. Now, remember, in order to prove those parts, first we had to prove those triangles are congruent, right? And AB is congruent to BC because of CPCTC, right? The corresponding parts of congruent triangles have to be congruent. All right. So again, your learning targets. can you critique a proof about quadrilaterals, right? Can you use diagonals, can you use their definitions to work with proofs of quadrilaterals? Can you prove theorems about quadrilaterals? All right, and that's really about the definitions and what they mean in terms of their sides and angles. I can rewrite a conjecture so it's specific enough to prove, right? So you would be looking at certain parts of a statement to be able to either break down the figure into triangles so you can start getting into your proofs a little bit faster and more efficiently. Okay, so that's the end of the lesson. Have a beautiful day.